All right, so with that, let's move forward now into actually talking about some of the workflows that we use for SEER. And as we move in and discuss these, you'll see a lot of the themes that David just talked about kind of wrapped in here and enhanced and pushed further, taking input from not just the wind engineering community, but ultimately taking in from the earthquake and what others have done as well. So let's start here. Okay, as Tracy mentioned, we have the two different kind of memberships within or groups in an event response. You have your VAST and then you have your FAST. And I know there's a lot of text up here. This is for all those at the conference who just take a picture of everything, so it's right there. But I want to highlight a couple of things. Okay, when we think about an event that happens, there's the different stages. You have the immediate post-event, or sorry, that should be pre-event. I'm sorry, immediate pre-event. You have the during deployment, you have the immediate post-deployment, and then you have the long-term post-deployment. And what I want to emphasize here is that the VAST and the FAST during each of these stages is one team working together to enhance the quality of the data and the robustness of the data sets that we were able to collect and the information that we were able to share. So for example, pre-event there in the far left where it actually says immediate post-event, but pre-event there, the VAST may be working on you initially form the VAST and you appoint a lead and then they're seeking all this information, everyone's collaborating on Slack, and then you're authoring and publishing the PVRR. At the same time, the FAST, if we are initiating a FAST deployment, they're beginning to secure reservations, coordinate logistics, all of that still through Slack, the common hub where we're sharing all this information. Then as you move during deployment, it doesn't stop. We're still a team that works together. The FAST, while they're in the field, they're collecting data using these kind of predetermined strategies and targets. They're preparing these daily summaries, sharing it with the VAST. While they're in the field, the VAST is back scattered all over the world, or really in some of our previous events. And they're reviewing these fulcrum, the entries, and they're reviewing the daily summaries. They're starting to build out their next report, the EARR. And then together, kind of these joint tasks are, disseminating where are teams in the field, what are we doing, what are we looking for, some early reports, sharing it beyond our community. And then you see the other, I'm not going to go through every single one of these, but as we go through, then even into the kind of the long term, then whether it's VAST or FAST is also going to be working on, okay, what are the ideas, what are we seeing here that we need to follow up on, maybe with hypothesis-driven research and pursue rapids. That's not just something for the FAST teams, that's something for anyone that's involved, or even it's just accessing the reports. And then things like, if you're looking for motivation to join the VAST, and even if you're not in the field, when we submit all the reports and when we go and publish journal papers, those that are participating in the VAST and have major roles and are working hard at doing it also are all included in the authorship of these reports and journals and so on that go forward. So it really it's this idea of how can we maximize the data sets that we collect beyond just the people who are in the field. Is the overarching goal of these workflows. So let's talk about these in a little bit more detail, try to get a sense for what these workflows look like. So one of the major aspects of this that we find very beneficial is this pre-deployment phase, and specifically the target selection. So by looking at collating all this information before we ever step foot in the field with the VAST and the FAST working together on this, we're able to identify, using satellite imagery, using social media, early reports, and so on, to identify points of interest. And as you said, points of interest being not just failures, but successes, anomalies, things that are different, things that we think we'll be able to learn a lot from. Once we've identified those, we can choose some representative samples across a diversity of structural typologies, hazard intensities, and so forth. And then we can even then start to match and say, okay, what do we think are good case studies? What are good areas that we want to study? Now, what FAST members do we have available that we can kind of mix and match and make sure we have expertise in the field that is able to take advantage of these targets and get the most information out of them? But then it's always re-emphasized that these, as we're developing these targets and putting everything together, giving them all this information, these are recommendations. I mean, certainly you as a FAST member, when you're in the field, if you see something of interest, then go for it. These are recommendations, not absolute. But having done it both ways, just go into the field and try to find what you can as you're going around, and having these, all this information available beforehand, takes so much stress off you knowing that you're going into the field with all these pre-identified targets and knowing kind of a daily schedule and so on that we're able to put together. The other nice thing about the tool that we're currently using in Fulcrum, and then with the RAP, they also have this functionality built into it that we can use one day as well, is the ability to take all this information, and instead of having it, maybe just kind of a printed out map, you actually have this embedded in in the smartphone app that we take. It can work offline, so you have all that information right there. You're informed as you go into the field. So in terms of the assessment technologies that we use, certainly our door-to-door technology is and will always be a major part of our workflows. But we're also supplementing that and taking advantage of some of these newer technologies, the unmanned aerial surveys, the applied street view and 360 imaging technologies, as well as the terrestrial LiDAR and aerial LiDAR and so on as well. So incorporating all these together, but not just, well, let's just send a UAV up here and let's do some LiDAR scans here, but how can we work efficiently bringing all these different technologies together and collectively get data that we're not going to get from any one of these separately? How can we work together with these? So a typical data collection strategy for us typically involves these overlapping technologies. So for example, if we take a neighborhood here, this was in Hurricane Michael, we may be doing all three of these in the same area. We've identified a cluster. In this case, it was a mix of kind of post-code improved to pre-code improved buildings, and we want to compare performance. So we're going to get some typically fairly detailed case studies using our door-to-door assessments, and then we're going to get street view camera throughout as well to capture broadly from the ground what we can see in all these structures. But then we're also going to use UAV to collect enough images to do a structure for motion, collect all that into a single model. And between all of these, we've got now a complete picture of that post-event damage state. And we can always go back then and find the context as well as the details of what we need in those structures. So then we'll talk briefly about the mobile apps. So right now, as Tracy mentioned, we're using the Fulcrum platform, and it's been a tremendous benefit to us. We're also working with the Rapid team and the RAP that they're developing to implement some of these same workflows into it. But the idea is when we go out and you see a structure of interest and you take a bunch of pictures and you jot down notes and so on, the ability, the benefit of a mobile app that we see in the workflow is that we can take all that information, these diverse data types, whether it's photos, audio, standardized form, notes, drawings, sketches, incorporate all of that into a single geolocated point. So then when we go back on a map later, all this information is stored in a single location. It's easy to transfer, easy to share, and easy to work with and enhance later. So you can look there on the right-hand side and see all the different data types that are contained within a single, what we call a record. And you build up a database of these records that has different, both kind of free-form information, media attachments, as well as these standardized fields within a form. And that's easily exportable and transferable and so on and expandable for as we move forward with additional deployments or additional enhancements to that. The other benefit of this approach, which we currently have with Fulcrum and also is being built into the RAP, is that we have the ability to do this real-time data sharing through the Fulcrum communities. As Tracy mentioned, anyone can go and see the data as it's being collected, which is useful for the NGOs and others that are trying to get that information as well. So currently our STEER app library consists of these apps here, and we say apps, but these are assessment forms, but with the ability to attach media and so on to them as well. So we've extensively used our building US windstorm app. We also have a non-building app that's more geared toward windstorms. We just created a STEER earthquake rapid evaluation form that is primarily based or loosely based on the ATC 20. And then we will be coming soon building out a more detailed earthquake and a tsunami that's responsive to your community's needs. What do you want to collect? What should we be collecting? And we have a workshop here on Saturday that's dedicated to finding that out. And afterwards we can build out apps and forms that meet the needs of these communities. Okay, so the idea, once we have this data then, what is then the benefit of what we're doing with kind of this vast and fast and the data enrichment that we're talking about? So I've put up here a picture of a building, and this is just a photo. If you've gone and done damage assessments, you've taken lots of photos. I would say here that you actually have three different types of data right here in this photo. One, you have the photo itself. It's a JPEG. It's a point of data itself. You also have the metadata associated with that photo, where it was taken, when it was taken, direction, orientation, and so forth. But you also have data that we want to extract from this. Okay, so you have a number of different things. Maybe it's damage, maybe it's the structural load path, maybe it's for wind, for example, the fenestration protection, or if you're coastal, maybe the first floor elevation, and so on. There's all this data that we want to be able to extract from this raw data that we're collecting in the field. Then we want to be able to look not just at that data, but maybe there's the other attributes to give context. When it was built, what's the occupancy type? Are there some retrofits that have been applied to it, and so forth. So these are all different data types. And so the idea with the FAST and the VAST is you only have a certain amount of time in the field. You have a certain amount of person hours that you can dedicate to being on site. So how can we maximize, maybe this is all data that we want to collect, what is absolutely necessary for someone on site to collect, and more versus can anyone look at this photo and pull out some of these other attributes. So that's the idea of kind of partitioning the data collection responsibilities. So maybe those things in orange are things that you've got to be on site to do, and we want to make sure that we do them while we're on site. But these other data, let's take advantage of these students or other people that are not able to be out in the field and use this as both a training and an engagement exercise to help them build out more robust data sets and kind of extend beyond just the person hours that we have in the field. By doing this as well, in order to do that, then we can also, the advantage of this approach is that we can also bring in all these other supplemental data sources. As you're in the field, there's only so much you can see on site. Maybe something has already been cleaned up some, or a roof has been replaced already, or repairs have already been made, and so forth, or you don't have access to the roof. Okay, so there's a certain amount of then enrichment that needs to happen, and this comes to being able to take these supplemental data sources, extract information from those, and again, aggregate all this data into a single record that is more useful ultimately to the structural engineering community and beyond. So that's what we call this data enrichment and quality control approach. Two different components of this. The data enrichment, bringing in these different data sources to fill out a more robust and complete data set. And then also the quality control, making sure that this data is consistent, it's accurate, it's valid, it's able to be, as Tracy mentioned, you can have confidence in it as you use it later going forward. And then we also have found, and one of our priorities in this approach is that this data enrichment and quality control process is a fantastic educational opportunity for students and younger members who are not done so much field research to really learn what data we're collecting, how it's collected, and what we can learn from it without them ever having to step foot in the field. So as part of this data enrichment and quality control, you'll see we bring it to different stages. Not every structure is worth going and doing a detailed case study of. So maybe in some that's only a stage 1 or a stage 2, just the bare minimum. Others you go the full, stage 3, stage 4, where it's more of a detailed case study and you're bringing in lots of other information. We have a way of essentially tagging those so that as you're using this data later on, you have an idea of how much data is included within each. So with all that, and this is a quick summary to give you an idea of what this workflow looks like. It brings us back here. The idea is what workflows can we develop that increases our efficiency, that makes the data that we collect more impactful, and take advantage of the fact of how early we're able to get there, take advantage of the efficiency that we're able to develop in these workflows, and ultimately create impactful data sets that are useful to not just us here in the room, but far beyond. Whether it's your training machine learning algorithms or whatever it is, you can take this data, have confidence in it, use it, and ultimately, as is our mission, generate knowledge, improve resilience for the future. So with that, let me wrap up and just do some acknowledgments. We certainly appreciate the National Science Foundation and Joy Pawski for her support and her vision in all of this. We acknowledge the Converge Node and the wider Extreme Events Consortium and just the fantastic work that's going on in between all of these and trying to work together here. We do appreciate Fulcrum Spatial Networks and the Fulcrum community and their being willing to make this available to us. And then certainly, last but definitely not least, is our members and their institutions and all the work that has gone in, much of it on a volunteer basis is what a lot of this happens. And we appreciate the enthusiasm and the willingness to jump in and be a part of this vision as it comes to fruition. So with that, we encourage you all to join our efforts. Go to steer.network and you can go through the steps there, and we would love to have you all as members of STEER, and I will leave that here for now.